Hi, everyone. Welcome to a new episode of Pints with Ayre. I'm Brent Heffley. I'm the Sales and Marketing Director for Ayre Acoustics. I'm here with Ariel Brown, our Senior Engineer and VP, and Ryan Berry, our CEO and Expert Technician. And as always, we're excited to share some new topics on audio and some new beers today. So what did you guys find there for this episode?
So based on a listener's recommendation, we weren't able to find the exact brewery they're talking about. We got the same brewery, so Weihenstephaner from Germany.
Awesome.
We got Weihenstephaner Fest beer. I've had one or two of their beers before, and I've always loved them. Really, really delicious. So
yeah,
happy to try this one.
Way to go seek that one out.
Yep.
That's awesome. And if anyone else has recommendations out there, throw them our way. pints@ayre.com. We'd love to explore some new stuff.
This is our first non-local Colorado beer. I know originally I was thinking at least that we would go through as many Colorado beers as possible, but we don't need to be that strict.
Oh, we've got plenty of episodes to do.
Right.
I'm sure we'll have a chance to cover them.
I sure hope so. And this is officially Oktoberfest period, or what would be normally, even though it's been canceled and officially in Germany. But
yeah, it's true.
It seems appropriate.
The last 2 weeks of September, beginning of October, it's time for some German beer. So
it is. I'll get there. I went with a very local one this week. It's Oakshire Brewing here in Eugene. It's their Reclaim the Fame West Coast IPA.
Wow.
70 IBUs. Beautiful label. You know, I'm all into the label. So this one totally was a label purchase. I bought this one strictly by the label. I didn't even know what style it was until I got home and looked at it. So Oakshire is a great little brewery here in Eugene. They have a tap house in Portland now as well. But great down home, very casual, fun place to go hang out. So good beers for our topic today, which is gain stage.
Oh boy.
Gain stages. What are they? What are they used for? What are the challenges? And what's our solution? So let's kind of dive in with some of the basics. And, everyone's probably heard the term gain stage, or maybe wrapped in different technology or whatever, but, what exactly is the gain stage? It makes something gain. It makes something bigger.
Well, sure. And so, gain stage, is, we're talking about an amplifier. A gain stage is the core of any amplifier circuit stage. Now, the word gain itself does not have to mean bigger. Gain can be negative. You can have negative gain if we're actually making a signal smaller. So if you were, a gain value is referred to in decibels. And so 0 dB means that you're not altering the signal level. So again, output level equals input level. And positive dB means you're making the signal bigger, and negative dB means you're making the signal smaller. So if you do a plus 6 dB, that you're doubling the signal level. And a minus 6 dB is halving the signal level. So the gain stage is, when you're talking about any preamplifier or power amplifier or any circuit in any source product where you are, at least in terms of audio, you're almost always making the signal bigger. That's the gain stage is the core circuit that amplifies the signal, and its properties, define, dominate the distortion and potentially the noise floor that your product is going to exhibit.
That's what turns it up to 11.
Right.
Which is kind of funny because, as I always looked at the K5, and, when you first power the K5 up, it starts out at volume level 11. So Well, I just had a kick
Yeah.
out of that.
Yeah, totally. I was trying to get my kids to watch that a couple weekends ago.
Yep.
Yeah, this is Spinal Tap. Very cool. So they're in any amplification product. So it could be a headphone amp, a phono amp, you know, a preamp. All of those have gain stages in them.
Yeah. Yeah. For instance, a phono stage, you know, it is receiving a tiny signal, you know, like
Right.
a couple millivolts or less, and you generally want to get to line level, which is a volt or a couple volts. And so, you know, in a phono stage, you have a lot of them. You have 40, 50, 60, 70 dB of gain, which is, you know, potentially 1,000 times bigger. So
Right.
it has to be a very very low noise and very low distortion gain stage to be able to do that well.
Yeah, I know that's one of the most challenging types of products to put a gain stage in.
Right. And it's something like a DAC or a CD player that has this DAC built into it. Yeah, you are the typically, you know, a DAC chip, depending on its technology and your converter stage depth, that you might be dealing with a few hundred millivolts is relatively common, and again, you're trying to get up to a couple volts.
Right.
So it's a bit more manageable in terms of that actual gain value, but it's still the same function.
Uh-huh.
And again, there's, you know, still a difference between single-ended and differential, and of course in Ayre products we always use a true differential gain stage.
Uh-huh. So in the gain stage and designing the gain stage, what are some of the biggest challenges of that? So obviously in a phono preamp, that's one of the most challenging. So you're going from a tiny signal up. What's probably the most biggest challenge in our design aspect?
Well, so it's, you know, it's really the two primary things are going to be noise and distortion.
Mm-hmm.
So I'm trying to say, so you're trying to, you know, minimize distortion, minimize noise, and not necessarily maximize gain, but you're trying to, you know, get the appropriate level of gain for that particular product and that particular function. And so, and at least for us, you know, in doing a differential stage, we have benefit of also trying to block or cancel incoming noise, any common mode noise.
Right.
And that's what that differential gain stage is really good at, is to actually cancel out common mode signals.
And then since we're not using any feedback loops in our products, what do we do design-wise to really minimize the distortion in a gain stage? Because I know that's something that you and Charlie previously worked on, you know, relentlessly.
Yeah. So for, you know, it's using the dominant factors, I believe, is using really linear transistors,
Mm-hmm.
and using it in using especially without, you know, like you said, without using feedback, you know, we have to rely on the actual topology and well-matched linear transistors to achieve, you know, respectable distortion.
It's really, you know, important to note because, you know, it's much easier to hit really, really strong numbers, and you'll see in a feedback system circuit, you know, you'll have really, really strong THD numbers. You know, they'll be extraordinarily low, but you know, we've tested those things here, and while the distortion is lower, unfortunately, the costs of having that feedback in the system from an acoustics sense outweigh the benefits of getting those lower THD numbers. Now, we're not saying that high levels of THD are acceptable by any means. I mean, you're still talking, you know, thousands of percentages and such to try to get this as low as possible. But, you know, the reality is without feedback, it is harder to to filter that out after the gain stage is done.
Mm-hmm.
Yeah, and so the other big constraint is that you want as low a noise as possible, and again that can be defined by the transistors you use, as well as even the quality of the resistors you use. Particularly low quality resistors can add a surprising amount of thermal noise and excuse me, noise to the system. And so we use our core gain stage circuit uses ultra low noise Toshiba JFETs that are no longer made, but we have a decent stock of.
We own a lot of them.
A gazillion of them.
Well, when you get something that sounds right, you can't let it go. And
yeah,
I think it was a great move because we haven't heard anything since that sounds as good as them.
Yeah, for sure. Now, there's probably a number of different types of gain stages out there. I know we started Ayre with probably a particular type. I don't even know if there was a name or a title for that type of gain stage before we developed what we currently use, which is the Equilock stage that Charlie and you developed with the MXR originally. Sure.
Yeah. No, I mean, our first product, it didn't even, the V3 didn't even use JFETs. It was I think entirely MOSFET. So yeah, it was a slightly different beast, and I'm looking back on that circuit, it still hurts my brain a little bit.
It works. We're just not sure why. It's kind of like the irrational but efficacious disc.
Well, yeah. So, yeah, pretty much, ever since our second product, the K1, the core of our products have been a JFET complementary differential gain stage. With the MXR, we were trying to improve on that a bit, and so it doesn't change the core JFET. It adds on to it, and so what it does, it helps to, I would say, linearize the JFETs even further. And so, we've talked about it quite a bit, and any particularly technical circuit designers out there will be able to read between the lines of what we've described it as before. It's essentially a special case of a cascode circuit that helps to fix the operating points around the JFETs, so that, and what that does is that in a non Equilock circuit, let me say, is that with the music signal, the voltages across that JFET will change, and when the voltage across the JFET, which is more its operating condition, some of its characteristics change, some of its parasitics, like its impedance and its parasitic capacitance change with the voltage across its terminals. And so with our Equilock circuit, we greatly reduce the changes that it sees. So that it sees a relatively constant voltage across its terminals. So now its capacitance and its impedance is now relatively constant, so that it can act much more linearly. And we saw, and we were able to measure a pretty big lowering of distortion. And we did listening tests, and we're very happy with his improvements there too. And so, yeah, we developed that in the MXR, and when we were working on the KXR, we used it and even refined it further, and that was one of the keys to us getting to double zero, or what I call double zero distortion number. So the 0.00, essentially 1% distortion, which is really respectable for a zero feedback circuit, and that made Charlie proud enough to actually call up one of his mentee that was the day he actually called up John Curl and actually bragged about getting to 0.001% distortion, the zero feedback JFET circuit. And John's like, nah, you can't be done. Go get it. And he was really, really proud of that.
Mhm.
Yeah, I know that, that Equilock circuit really satisfied one of his original goals of making solid state gear that sounds a lot like tube gear.
Yes.
Because in Charlie's own story, he only owned tube gear
Right.
until he started Ayre. Like, he loved tubes, he loved the sound, but it made him crazy because you never know when tubes are exactly right, when they're on their way down.
Where your next ones are going to come from.
Right.
Yeah, all the factors that go into that, which is definitely a passion.
And that whole kind of concept really is mimicking the way tubes work a little, where their operating conditions are really more mechanically defined. They have plates and a grid that is, so its capacitance, all its operating conditions are fixed mechanically. It's not and so this whole circuit actually mimics that quite a bit.
Right. So it locks those values in like a tube would, and then lets the JFET basically act more as a tube would in the system.
In a sense, yes.
Yeah. Yeah. It's super cool because tubes do some magical things, and being able to get really, really close to that same effect with solid state, where you have the reliability and you have the bass impact and things that tubes don't do very well, is such a great solution.
Right. And so with the Equilock circuit, now that circuit is now used in all of our products across the range. So from our high-end products to our entry-level products, how it's implemented is what varies with those ranges, because in the R series stuff we throw a lot at it, and then we simplify it for our less expensive products. But it's still there, and it still affects the same results.
Yeah, I love the fact that we can do that and bring so much of that technology, those circuit designs, all the way through the line whenever we possibly can, because it makes our entry-level stuff such a great value. The top-end stuff's still better because we can put more money into it. We can put higher-end components, but you get the same Ayre sound throughout the line. I think that's super valuable.
I think that's our biggest challenge with design is knowing when to stop on a design. Honestly, we always want to make the next thing the best thing we've ever made. So
absolutely,
it's really challenging from any design standpoint. And I'm sure every designer faces this to different degrees. Is where do you draw that line between putting everything you can possibly throw at it and trying to keep the price at a reasonable level for the consumers. So if it were up to us, we design a $10,000 amplifier every day, and then want to sell it for $1,000, but you still have to unfortunately design it for what you're aiming for.
That's what happens when you're designing for yourself. When you're designing products you want to own,
yeah,
it's like the build your own online. You're like, oh yeah, I'll just add that, and I'll add that, and I'll add that, and you're like, oh, that's a little expensive. What else?
Yeah, exactly. Oh, wait a minute, maybe I don't need liquid cooling on this computer, or
right.
Exactly right.
Yeah, maybe we need a system like that on our website where you can like design your own Ayre product by module.
There you go.
Fun.
That would be awesome.
You're giving me a headache just thinking about maintaining that inventory.
Oh, that's my job.
There you go.
Good. So we've been doing the Equilock since the MXRs were introduced in 2006.
Yep.
Right? So it's migrated into all the other products at some varying degree.
Yeah. Any of the products that use the JFET differential stage, which is nearly all of them.
Right.
Nearly.
Yeah. Okay. Wonderful. That's great. Anything else on that topic? I think that kind of covers
I don't think so.
Most of it. Cool. All right. Well, cheers to that.
Cheers.
Yeah. If you guys are out there, you have questions about Equilock, about gain stages, or thoughts for other topics, email us at pints@ayre.com. And otherwise, until next time, enjoy the music and the beer.
Thanks, guys.
Take care.